Hi, I'm Stephen Orvis, and today I'm going to talk about binary trees and show a little bit of code around them too. So binary trees is one of my favorite data structures. I've been fascinated by them ever since college, and I've gotten to use them in an open source project, which I am going to show today. Uh, so the basic concept with a binary tree, and this is the wiki page here, you can just go there, I'll put it in the description. You can go to a start of a binary tree, and then the idea is the data is structured underneath it. And so the concept is if you're finding something, you can walk through the tree. So in this case, they have numbers laid out. So suppose you have a number that is 199, and you need to find that node. So in that case, you break it down by numbers. So you start with 1, say, okay, I'm at 1. And then what's the next number I need? It's 9. So you go to 9. And what's the next number I need? It's 9. You stop at 9. And that node has what you need in it. That's the one you're looking for. So it's a neat concept, and it's also neat how you can actually follow other complex trails going into, and hopefully I'll get into that some here with the code. So the point is, this is fast. Uh, you just have a link in your code between the nodes, and the nodes know how to find the other node, and then that allows you to uh, go ahead and walk through it quickly, versus if I wanted to find the 1991, I imagine I'd have a list. I'd have ones, I'd have 19s, 199s, 195, 995s, 17s, 176, 1711, so on and so forth. And so this is quite the list. So how are you going to find an item in that list? Unless it's hashed or something like that, you're going to have to iterate through each one, each one, each one, each one until you find the right one. And again for as you call it, was this your speed is super fast because you're linked list, and it just goes right to the place where you need to be. So it's a neat advantage for very big sets of data. So when I learned about this algorithm, I was like, where's the big set of data? And I thought about the Bible, and my father had used a tool years ago, and they no longer supported it, and I made a clone of it. And in part of making the clone, I went ahead and I utilized uh, a binary tree to do it. So that was super cool. It made search really fast. You could search words in the Bible super fast because they're a binary tree, and as you're typing, it can just pull them all up because it's on that node of the tree. So that was the other cool thing. The search as you type. As you're typing, you type in 1, you have everything that 1 is. And then you type in the 9, and you have everything that 19 is. You type in 199, and you have everything that 199 is. This is like instant. It's like right there for you. So it's a neat data structure for that. So this is also on GitHub. I'll put the link in the description. And it's open source, and anyone is free to download it and play with it. I haven't touched this for quite a few years. My 11 for this file. My father actually still uses the program from time to time, so once in a while I'll do a bug fix for him. But I think he's the only user out there. But it works. It's fun. It does have some cool features like you pick Bible verses. It lets you search them. It lets you export them as a printable document, and then it also allows uh, you to export them as computer read audio files. So it's nice if you have specific verses and you want to listen to them in a loop or something, and you just only want those like 10 various random verses. So it's super good for that. It does have the computerized voice though, so it's something you have to deal with if it's something you want. All right, on to binary trees. So I started coming in here, I was going to prep for the video, but then I was like, well, I'll just do some of it live. So I found the file. I think it's actually good showing the process though of how you get to places. So 11 years is a while back. I've been in and out, but it's been a while. So I'm just going to stumble around through here and also show how, as a developer, how you dig through code that maybe you don't know or is just really old. I know at work sometimes they'd ask me, "Oh, how does this work?" I'm like, "That was 6 years ago." Let me look. So we don't always remember everything. All right, so I'm going to jump in. And why did I click FastScript? Just at the top here, I had some framework stuff. So I'm hoping that probably it's down in here under FastScript. In here, I see some sort of the lame shell, I believe, was some sort of a library I used. I have some memory presenter folder. Pretty sure it's not there. And I see a Bible reader, Bible data. I'm going to jump in the reader because that's going to be parsing it. Bible builder, that was the first file I went to. I came in here and I see this is Zenaphala XML Bible markup language. So there's a standard that I had found way back when of Bible languages or Bible formats, and I had wrote my code around that. So you theoretically could import other Bibles into this program. Even though I have one Bible that I've by default put into it. All right. So this is calling Open XML Zaphania XML Bible markup language. So that's the class name there. I think I did underscores. I don't think that's technically C# convention. This is way back when during college era, slightly after or something like that. I don't think I had a that was before I had my summer job, so this might have been halfway through college. All right. So we have what do we have coming in here? We have file location, book manipulator. That might be an interesting class later to look into. And I don't see any inheritance on this class. So I'm coming into here. I've got a using on a reader. It's gonna got a title. It's reading an element. Okay, so we've got some XML elements: Bible, book, chapter, verse. It's getting a verse number. It's going to do some more reading. Send book to data tree. That would be the place. And then down here, I see private void, send book, send to data tree, and I see, and it goes to underscore Bible dot add verse. It sends a verse string, it sends a book. Okay, yep. So the book is a string, number, chapter is a number, the verse is a string. Makes sense. All right, so it parses the XML, gets it into something standard, and then sends here. All right. So we need to find a Bible. Where's Bible? It's the manipulator. The manipulator is Bible book.manipulator. So I'm gonna jump up Bible book.manipulator. Maybe in here. We can search it if it's not in here. Book manipulator. That's probably it. My naming convention back then was pretty bad. I think that's like look at that. There I do uppercase first letter. There I'm like, okay, we'll just do it do it second word. Anyways, so the code works. Maybe someday I'll fix it in my free time. Alright, so we have a book manipulator, and it has a Bible. It has a Bible hash. And there's the constructor. Get the Bible. Alright, get verse. What was the function? I think it was add verse. There's add verse right there. So we have verse, book, chapter. Okay, so add chapter calls the function. It has current chapter. So you added the chapter, and then you ask the Bible. I love how it's like a local uh, variable here, but then there apparently. Oh, I guess this is function add book. You had a book. Oh, there. Yeah, see, that's what I'm talking about. So here it's referencing a local variable, but up there it wasn't. I guess it's not too bad. Okay. At least it's my code, so I can be critical of it, not hurt anyone's feelings. So back to this. So add chapter, and then current chapter. So it's going to get that. So I think when it added the chapter, the idea is you need to add it before you do it. Now I would actually make that maybe one function like add and get, or add or get, or something like that, because you can just clean that up. No reason to have two lines there. That's probably one of those functions that doesn't do anything if it already exists, so it doesn't hurt to call it multiple times is what that looks like. Alright, so current chapter, it gets that. And then if current chapter get verse, so we're going to give it the verse number, and then like, oh, if it's not there, or replace, that's interesting. So we had a way to force it. That, oh, you know what, if we're reading in a XML file a second time, I betcha, we'd want to overwrite things. So that might have been some trick to do that. Don't remember, just a theory. Alright, current chapter. We have a current chapter because we added it and got it. We had the verse on the Bible hash. Okay, well, let's see what. Can we just jump over here? Get hub is much better than they used to be. So I super like their jump to things that they have now that they didn't used to have. So I have to make it go there. Like the camera's over it, maybe? Nope. Bible hash adverse. It's not helping us. Alright. So we have adverse, we just search it, the repository. So in C#, you can often search, and I've been doing too much Python. You could search like a parenthesis or something, and then it would come up with, alright, not being indexed, is being indexed. Oh, interesting. That's fun that GitHub apparently doesn't have active indexes of things. Alright, that might be why I was having trouble. Oh, look at that, they have different symbols over here too. So there's a function adverse that jumped me there. I'm in book manipulator now. Current chapter adverse. Oh, okay, I see. It took me back to where it was at in this file. Adverse. Yeah, that one. Oh, interesting. Okay. It's not going to help us. Alright, so normally, if I'm just in Visual Studio, I would be searching for that adverse. You could do space adverse and then parenthesis or something like that, and it would find that function quite likely. So we have current chapter adverse, Bible hash. The Bible hash is probably going to be where we're at. We might just go to current chapter and see what that is. So where's that defined? That's a book. Where is book defined? No, current chapter. That came from Bible. It came from Bible. That makes sense. Okay. So we have Bible and we have Bible hash. Bible is of type Bible. Bible hash table. Okay, I think we're done with this file. So here's Bible and here's the Bible hash table. I bet you I named that badly. Alright, so we have a Bible. This looks like it's going to be the data structure. So I see verses, books, book index, a manipulator, and an index. Alright. So we have a background worker in here. Interesting. Here is a list. Okay, so I'm initializing it all. Build index. So we built the index. That might be interesting later on, because that quite likely, it could be I read it in just the data structure raw and then I processed it after the fact instead of processing it as I read it in, maybe. As I do remember, yeah, I don't know, it'd be interesting, because we definitely ran the job every single time the program started. We'd run the index job all over again. Okay, we have getVerse, and it uses that manipulator, whatever that is. Book manipulator. That will be an interesting class. Add book, remove book. That doesn't look horribly exciting. Is the manipulator there? Yeah. Alright. It's got the Bible hash. That's going to be interesting. So it takes a Bible. That makes sense. Of course, they all know about everyone else's existence. And we have the Bible. Bible hash getVerse. You give it a book. Oh, look at that. So we have a book, a chapter, and then we have a verse number. So it literally looks like we have a way to return verses quickly, and we used a hash table on that. So I might have used multiple data structures here for different use cases. Probably this is the selector where you can go through, drill down by chapter, book, chapter, verse, and so that's likely what this hash is doing, I bet you. So it's a range of verses, so you can get a range too. Yeah, that's really what that looks like, because the selector lets you select multiple. Oh, here's add verse. Look at that. So add chapter. Gets to the chapter. Adds the verse. Gets the book. Adds the chapter. So book. Probably has interesting stuff in it too. So the book has a chapter, a title. Chapter list is an int array. Interesting. Hmm. Yeah, because I would have expected either a hash, maybe not a hash, even just an array could have worked. You could just make an array this size for the chapters or something. I don't know. So get chapter, gets the number. That the number is greater than the chapter count. Return nothing. It's not. Oh, so there is an array out there. Yeah, the chapter. Oh, we used the list. Okay. Yeah. So yeah, I feel like when we init, we give it a list of numbers. Interesting. I think, and I don't know if this is true of chapters, but some Bible versions don't have certain verses, and so I wasn't exactly coding for that because I use the King James, so it's not really a problem there. But I think I kind of had that in the back of my mind that some Bible versions might be different, and so I might have let some code be different just to allow for that case potentially if it was needed. But I don't think overall it's supported by the program because I haven't really tested that. Okay, so add chapter and right. Okay, so we have the book here, and we're interested in that hash. I think that's going to be. Oh, let's look at chapter. We have a chapter, and chapter is verses. Get number of verses. It counts it. Get a verse. Add a verse. Just adds. So it's just like a list. That makes sense. All right. Is a verse is a string. So when we do an add, how does that work? You do first number. Oh, okay. So you just pop it right in where it belongs. Okay, that makes sense. That hash table. That's going to be the one I think. All right. Get a Bible hash. And this hash table. List of verses. And did we see verse yet? I don't think we saw verses. Okay. Maybe it's stuffed in one of these other ones. Or in a different folder. I'd be one if I was doing a code review. Find that. Oh, wait. Is it? It's under data index. Oh, okay. Fun. Yeah, I think. Yeah, anyways. Yeah, that should have been with other files. Hey, does that mean we can just click and go there? Did GitHub finally work for us? Hey, look at that. Now that's how GitHub's supposed to work. So this verse, iserializable, has a string of a book. Could have been a reference to a book. Chapter number, verse text. Int 16. Serializable. Okay, that's fine. It works. Bible hash. Let's see here. Can do a add a verse. Oh no, this looks like that function we were looking at earlier. So book, chapter number, verse number, string for the verse. And we do a new verse, which we just looked at verse. We add it to this list. And we're going to get the hash code. Okay. For fun, let's look. What is the hash code? Oh, okay. Book, chapter number, verse number. I think we're still in the wrong place. I think we're looking at the code for selecting them from the list. I don't think we found the binary tree yet. All right, let's jump back. Where were we at? We were in the book manipulator. Someplace in there, it adds. So, add verse, add chapter. All right, I think we've gone through most of those files there. So we have data index. Index sounds trendy and good. So Has a word. And a word is going to be closer because you can't pick words in that drill down. You can go book, chapter, verse number, words it stops. So words is going to be closer to this binary tree. Okay, so we have a word that's serializable, and a word has verses. That makes sense. And if you make a word with a word, all right, and it gets a word, and then a word can have a verse added to it. So that is going to be definitely part of this index. Because the concept was the binary tree is words, and for each word in the Bible, every single word in the Bible, you iterate through the binary tree and you attach it to its node. So what you end up with then on this tree, the is going to happen, what, 100 gazillion times? So the will have all the verses attached to it, and that's what's happening right here. Every single time you add the verse on, it's going to attach it. So if we find that, whoever that's called, if that shows up, which it's not, whoever calls that is going to be iterating through every single word in the verse and adding them to this. Okay, so we know for sure if we, when GitHub finishes indexing the repository, that if we search for usages of Word, that would probably get us to where we're going. But I think we're going to be in here anyways. Did we? I think we looked at first because we were over here complaining about the folder location, which I can see why I put it there, but sometimes there's not a right answer. All right, so we have an index reader writer. We have an index builder. Probably the reader writer isn't what we want. Probably the builder. Haha. Yep. So serialize, deserialize. Simple. All right. Index builder. Serializable. It has a Bible. We're going to cross that before. And this is before C# could do the property and backing field at the same time, I believe. That's been a while. I forgot that it used to not be a thing. That's one of the things I've liked about the C# framework. They seem to roll out good features to make life easier. So there's little things like that just save you headache. The hash table. Let's see what else. Index builder, dictionary. Okay, so get object data, build index. This looks complex and interesting. All right. So book list, get all books. You got a chapter list. So we're going to reuse that variable. First list also going to get reused. And a word list also going to get reused. First number is going to be set there. All right. So for each book in book list, and each chapter in chapter, wait. So chapter list, so we got book, that chapter list. There we go, okay. So each book, and then you have the chapter list goes to chapter, because I had the namespace, that threw me. Okay, so then you're looking through each chapter, so we're inside of a chapter, and then we're going to get the verses. We have the verses. So then now inside the verses, within the chapter, we're going to split on space, which is because the verse, as I recall, was just a string. So that makes sense. We're going to split on space. And then my next question was, what about punctuation? And then I see the function right there. So great. So we're going to pick out all the words, and then it would go ahead and knock off any punctuation. So that makes sense. And for each word in word list, add the word. So there's a local function apparently. And then it has title. So this is what I was talking about earlier. So there's a word hash. So add word. Where's add word at? Add word right here. So verse word. So then word node. Try get value. Word out of node. Check if word is in the dictionary. Then to the node you add the verse. The word is not in the dictionary. So I think we had a dictionary of so right? So I think this is dictionary might be more for building the data structure than using the data structure. So you have the binary tree. It might be just a set of words, and we're like collecting all the words we need to build for the binary tree, which I'm not sure is necessary. You probably could just build the binary tree as you go and not need the in-between step. So that's interesting. All right, so we have add word. We looked at that. And then we're going to go back in the word hash. And we're going to just get a hash out of the word and set the verse number. Okay. Get word, get all the verses for our word from dictionary. And what else here? Get verse, compare verses. All right, this still seems not binary tree focused. That split, because we got it done by word, but we still didn't look at it by letter. And that's where we would need to be at, is getting down to the letter. So there's got to be something else. So we have the index, the reader, writer. I think we've been through that stuff. We have data index, Bible data. And let's see if we have search powers yet. Tree. Oh, we do. Nice. Okay. Send data to tree. Book nebula. As Bible tree. Data as tree. Okay. Add verse. That was where we were at, though. So that is interesting. And I thought the use of node was interesting too back in that last file we looked at, because that would be what it is a node. So I must have been thinking node. Alright, so word. What does word do? Have we explored all that it has? So Bible index, try get value. Can I go to there? Try get value, Bible index. That might be worth looking into. Let's see. Try get value, index builder. And then it's just calling. So try get value. That must be a core system. Alright. Let's see here. That seemed like the bulk of the data model. That processing function we were at, where it was looping through, that's going to be heavy processing, so I don't see why that would not be really, really close to what we're looking for. Wait, was index builder? I think it was index builder. Build index. Get the chapters, get the verses, split, add word. Oh, look at that, get phrase. Find all common verses from a phrase. For each item, oh look, in phrase, split. So that's splitting on words, so it's going to get multiple words and do a search there. Get the first littlest word last. This will help efficiency somewhat. Compare verses. Find all common verses among word list. This is interesting. I don't know what some of these functions were used for. Why we'd be comparing verses. words that start with. Does the UI use this? Ooh. Presenter, it does. What function? What a function. Okay, search string. Yeah. So this is the presenter, so that's gonna should be calling whatever core logic, which it does jump down to the words that start with. It's gonna be disappointing if we get to the end of this and find out I swapped out the binary tree for something else. Alright. So I have a search. Found the book. I think I must have allowed for searching books, because you might be like, oh, Jeremiah. That way it would find that book in addition to any time that Jeremiah appears within the Bible. I think that's what's going on there. I kind of remember this function. I think there's some rework. If this was ever a real project that was getting more interaction, I think there was some effort that needed to happen in here. So then view that search suggestions, search box suggestions. Look for reference numbers. Get possible verses. Index.get possible verses. That sounds really interesting. Backend current verses. Oh no, that's book chapter. That's not. Not a reference, so do a search of the index. Backend. Words that start with. So that, I'm not convinced that that was the right function we looked at then. Words that start with it. Looks like it's a string. Let's search this. What do we need here? Space. I do this, space, like that. Yeah, look, it got the space there. So it just gave me the functions. Main fake window. That sounds like a hack. Oh, it's a test, okay. So then we've got an interface. And we've got UI code. Alright, fine, let's go see it. Data sources, drop down list. It's got a selection. Okay, so that was setting UI stuff. Not what we needed. Dead end. Alright. Oh, and it said view too. I was mistrusting myself from years ago that maybe I did it wrong and I had logic in the view, but maybe I didn't do that. Look for reference books. Else if found book. Found book is true. Look for references. Oh, right, because the search, you could type in a book. I think you type in chapter, verse, and it would go find it for you. So this was a better search than I remembered. Alright, so, but I'm missing then the string search. That's what I'm after here. So, found book, last book. I mean, I would probably search for books first. You would think, get the easy ones out of the way. Found book, false. Oh, because you could do reference ranges. I had a lot of features in there. Reference numbers. So just dealing with chapters. If search phrase. Do index search if needed. Count for a space at the end. That sounds like a fun bug. Display versus append reference list. Backend search phrase. Backend initializers. When FastScript is not in any of the initial data folders. So get versus, and you pass it the phrase, and then that'll give you verses, and then it's just going to add new list, reference list. Ah, this is references. I think that get verses is going to be where we're at. So that is Bible.index. Is that index builder? Yeah. So we're back to where we started. Alright, so it has a phrase. If I find all common verses from a phrase, so it has all the words, and then it's going to take the phrase and split it. And then all the words that are get word. You're not going to help me? Okay, that's fine. Get all verses for a word from dictionary. It is kind of looking like we don't exactly have a binary tree here, because that's just a dictionary with words. Alright. Where are we at? The phrase. Get phrases. Get all words. Where's all words that come from? We set it here. So we did the item get word. Get word's probably a simple, probably trim, does a trim or something. Gets all verses for a word from dictionary. Yeah, so that's what it is. It's not actually a binary tree, then it's matching, doing the whole word match. So I guess that means then that as you search, you would simply end up with a good match. So then if you type in half a word like go, it wouldn't find God until you put the D on the end. So what the implication is there. Unless it does something else, but I think we've been there. And Bible index is what? Well, where's Bible index defined? It's just a dictionary. So we have a dictionary. So my guess is that at some point in time, I realized that my cool binary tree wasn't needed, and I refactored, which is good. I haven't been in this code this deep for quite a while, so this was fun. I'm going to, before I call it quits on this, I'm going to find tests and see if there's anything interesting there. I'm kind of guessing no, but it doesn't hurt. Index looker, pre-search string builder. too much there. And string parsing, search parsing test. Arrays equal, capitalize word test. Yeah, I don't see anything in there that looks like binary tree stuff. Alright. Well, it looks like the binary tree was probably a POC stage. Again, 11-ish years ago. Probably 13. Okay, yeah. Probably I did other work. I remember it was a long time. So I believe 13 when I added the repository. I probably didn't even have it on GitHub when I first did this. Oh, I do have a nice readme. So anyways, it looks like the search backend ended up being just a dictionary and just a full list of verses, which makes sense. The hash is pretty fast, so you quickly find it. And building out a manual binary tree apparently wasn't as beneficial. And I think now my brain's like processing this a bit more. If you use the binary tree, it get interesting if you're searching multiple words. If you're searching one word, it's okay. And you can do search as you type, but if you do multiple words, now you almost need to run the tree twice, once for each word, versus the hash. You can just be like, oh, get me all the verses from this hash and all the verses from this hash of the word and this other hash of the word. So I can see why maybe a hash was better there. Binary tree would allow more real-time searching. If you weren't sure how to spell a full word or something, it'd be helpful. But it looked like I improved the search in that one presenter there quite significantly, so that you could handle references and a bunch of other things. So that's where I'm thinking the character by character search maybe wasn't as necessary, and word by word search was okay. So we don't always get to use actual raw data structures when we code things. Sometimes it's not the best fit, and I think this is a case of that, where it wasn't the best fit, and I ended up using just a dictionary instead. So not as exciting as the binary tree, but it at least had a good look through the code, and that's how you can search through and find stuff. What you remember is not always what's there. So it was good running through this and brushing up on it, seeing how the project is, and now I have fixed the misconception in my brain that there is a binary tree in here.